workshop on image processing with OpenCV. So, Convener of Dr. MVVS Nagendranadh sir, welcome to the session, and coordinator of Mr. T. Uday Kumar, Assistant Professor of Sasi Institute of Technology. Thank you for giving this opportunity. Yeah, today's session is image processing with OpenCV. So what is image processing? What is OpenCV? Which technologies we are using and which software we are using? We know about, before that we know about artificial intelligence. So why? Because we are in real-time applications, we are using the AI based artificial intelligence. So what is artificial intelligence? So first we know about what is intelligence. Intelligence is nothing but if the task is done by humans, called it as natural intelligence. If we add human intelligence to machine means it can be called as artificial intelligence. So what is artificial intelligence? So artificial intelligence So what is intelligence? So intelligence is nothing but if the task is done by the humans, it is called as natural intelligence. What is artificial intelligence? So if we add humans intelligence to machine means it can be called as a artificial intelligence. What is the meaning of artificial intelligence? The artificial intelligence applies advanced analysis and logic based technique including machine learning to interrupt events, support time, automate decisions, and take actions. So, about AI. So, artificial intelligence is nothing but subset of machine learning and deep learning. What is machine learning? So, machine learning is a prediction of ability to learn without being explicitly programmed. So, what is deep learning? So, deep learning is based on deep neural networks. Artificial intelligence is a programs with the ability to learn and reason like humans. What is machine learning? So machine learning algorithms with the ability to learn without being explicitly programmed. So what is deep learning? Deep learning is a combination of neural networks. The subset of machine learning in which artificial neural networks adapt and learn from vast amounts of data. Machine learning with Python. So machine learning is a we are using the supervised and unsupervised learning. What is supervised learning? Supervised learning is a machine learning technique where a model learns from labeled data, which input data pointed paid with a corresponding output label. The model then generalizes from these examples to make predictions or decisions on new, unseen data. It's commonly used to task in classification and regression. learning. Unsupervised learning is a machine learning technique where the model learn patterns and structures from data without explicit supervision. The goal is to uncover hidden patterns or relationship within the data. Clustering and dimensionality reduction are common tasks in unsupervised learning. Unsupervised learning is a unlabeled data. So it comes under machine learning applications like e-commerce and services, banking and entertainment, and image segmentation. So e-commerce is nothing but is a customer's transactional data and recommendations. Services, so for the medical applications, we are recommending the drug recommendations, we are using the services. So recommendations of travel services as a recommendation of houses to rent are matchmaking services. So banking sectors, in a banking sectors, customers based on their financial transactions and clusters the data fraudulent transactions for fraud detection. Coming to entertainment applications, so for the movie recommendations and like examples of Netflix and Amazon and videos and movies. So image segmentation, so image segmentation is nothing but a cluster images portions based on nearest pixel values. So what is reinforcement learning? So reinforcement learning we are using in real-time applications is a combination of computer and interface environment. The reinforcement learning is a type of machine learning where an agent learns to make decisions by interfacing with an environment. It receives feedback in the form of rewards or penalties for its actions and allowing to learn optimal behavior to achieve its goals. So it is a combination of computers with interfacing with an environment. It is used in real-time applications. What is a neuron? So it's a combination of neurons. A neuron is a basic unit of the nervous system responsible for transmitting information throughout the body in the context of artificial neural networks. A neuron is a computational unit, receives input signals, processes them and produces output signals. It is the function of biological neurons by applying mathematical operations to the input signals and passing the result to the neurons. So is structure of machine learning and deep learning. So input in the machine learning is nothing but we are predicting the output. Coming to deep learning. So from the input we are detecting the output. So first we are taking the, in machine learning mostly we are using the machine learning CSV data, like Excel sheet data we are using for the prediction values. First
classification with algorithms. Coming to deep learning. So input in deep learning we are using the input images or videos or audio files and feature extractions plus classification. In the deep learning we are using mostly images and audios and stored data and video streaming. So in the for the input data we are taking the images like 2D vector images we are using the input. So feature extraction in the 2D images we are using the vectorization plus classification. For the classification we are using deep learning techniques. In the deep learning techniques we are having the different types of classifications like RNN and CNN. So number of algorithms we having for the classification. Then it will detect with compare with the data set. What is deep learning? So deep learning is a subset of machine learning where artificial intelligence networks partially deep neural network with multiple layers used to learn represent a complex pattern in data. It involves training models on large amounts of data to automatically run hierarchical representations of the input data. This is also one of the deep learning applications like human behavior with emotion using Python and AI. This is also one of the artificial intelligence based on the one of the applications, human behavior with emotion. So how will detect a human behavior? So based on the emotions input we are taking the data set like happy face related frontal face images and emotion based images we are taking the XML files. For the face recognition, based on the face recognition we will recognize the human activity or human behavior like happy, sad, angry, laugh, curious, scared, confused, embarrassed, excited, struggle. This is also one of the AI applications. So we are using with the OpenCV. So why we are using OpenCV? For the face recognition, through the computer vision we are recognizing the face. Based on the input data set we are detecting the face, recognizing the face emotion. For the face recognition we are using hair cascade classifier. For the hair cascade classifier we are using for face recognition. Like input data set we are using the frontal face images and emotion based images. So for the face recognition in the one person human face having total 68 landmarks. Based on the landmarks we are recognize the face. So for the face recognition we are using hair cascade classifier. Next, robot applications. So in the robot application we are using the deep learning techniques. So in the deep learning techniques we are using the like CNN algorithms and YOLO we are using the like moving and pick-upping the movements for using the Python and AI. So this is also one of the deep learning neural network, and this is also one of the applications in healthcare chatbot. In the present days, no need to consult a doctor. Without to consult a doctor, with AI based healthcare chatbot, we are using AI. In the machine learning models we are using like NLP models we are using. So this is also one of the applications of AI and OpenCV. So traffic applications, how many vehicles it's in the traffic, we are detecting the vehicles count and the speed, how many four-wheelers is there, how many two-wheelers vehicles is there, we are detecting the with OpenCV, computer vision. Next, image processing. Coming to image processing, what is image processing? So in the image processing we having the two different types of process. One is the image processing is a method perform options and image. Analog in image processing techniques we having the analog signal processing and one more digital signal processing. So what is what is image processing? Image processing is a method of converting an image into digital form and performing operations on it to enhancement or extract useful information. It involves techniques such as filtering, segmentation and feature extraction and pattern recognition to analyze, manipulate and interpret images for various applications like medical imaging and surveillance applications, remote sensing and computer vision. What is analog signal processing? Analog signal processing is a one-dimensional image. So it is input equal to outputs, like examples of flexi and printing and Xerox. What is digital image processing? So digital image processing is it is to the editing options. So input we are taking the image or video or audio files. So pre-processing is nothing but resize, reshape and color conversions. In the image processing we having the three types of images like color image and black and white image and grayscale image. So coming to image, so color image having 0 to 255 range. It has a 3 channels, blue, green, red. So coming to grayscale image. So grayscale image having the 0 to 255 range, it has a 2 channels. And next black and white. So black and white range has a 0 or 1 binary and threshold values. Coming to image processing techniques. So techniques of image processing like filtering, segmentation, feature extraction and image enhancement, morphological. What is pixel? Picture is a smallest controllable element of a digital image. It is a single point in a raster image which is a grid of pixels arranged in rows and columns. Each pixel represents a specific color or grayscale value and contributes to the overall appearance of the image. The color of a pixel is typically represented using a combination of red, green and blue RGB values in a digital images. Although other colors models such as CMYK, cyan, magenta, yellow, black are also used in some context. Pixels are the building blocks of digital images and are manipulated and processed to create, edit and display visual content on electronic devices such as computer, monitors, smartphones and digital cameras. What is image techniques? Image processing techniques is nothing but filter, image acquisition and segmentation, image enhancement, feature extraction and morphological processing, image registration, object detection and recognition, image compression, image restoration, geometric transformation. So what is filtering? What is acquisition? So acquisition is nothing but image registration. So input we are taking the here images and videos. So we are converting the pre-processing step, resize, reshape and color conversions. What is filtering? What is image enhancement? So Image enhancement is nothing but adjusting the visual quality of images by modifying attributes like brightness, contrast, and color balance to improve clarity and detail. So what is image segmentation? So image segmentation is nothing but partitioning an image into meaningful regions or objects to simplify analysis or enable further processing, often used in tasks like object detection and medical image analysis. What is recognition? So identifying the locating specific objects or patterns within a image. So using techniques like matching, features based methods or deep learning based approaches. What is restoration? So image restoration is nothing but recovering or improving the quality of degraded or damaged images by removing the noise, blur or other artifacts commonly used in medical image and forensic analysis. What is compression? Image compression is nothing but reducing the size of the images to save storage spaces or transmission bandwidth while maintaining acceptable image quality using we having the different types of images extensions like JPEG, PNG, JPG images. So for that compressions we are using. So what is the compression? So reducing the size of the images to save storage space or transmission bandwidth while maintaining acceptable image quality using like JPEG images or PNG images or MPEG compression. Next, what is feature extraction? Feature extraction is nothing but feature extraction also is one of the technique of the image processing, identifying and extracting relevant features from images such as edges, corners, textures or color histograms, which are then used terms like object recognizing a classification. What is image fusion? Image fusion is a nothing but process of combining information from multiple images of the same scene or object to create a single composite image that contains more comprehensive and valuable information than of the individual input images. What is image retrieval? Image retrieval is nothing but like content based image retrieval. So image is the process of searching for digital images in large database based on their visual content or similarity to a queried image. So it involves comparing the features of the query image with those images in the database to identify the relevant matches. So for that we are using the image retrieval. So what coming to image steganography? What is image steganography? So image steganography is nothing but is the practice of hidden secret information or data with an image file in a such a way that extension of hidden information is concealed. So unlike cryptography, focus on making the content of message unintelligible and unauthorized users, steganography main aim of the steganography hide the extents of message, embedding the hidden data within images like So image acquisition. So image acquisition is input gives from images or videos. So data, like here data set. So image acquisition is nothing but data set, input image. So from the input we are using the images or videos. So pre-processing. So pre-processing is nothing but resize, reshape and color conversion. So for why we are using the pre-processing step? So for the resize and conversions and reshape. So for the reducing the complexity. So resizing the image and color conversions. So from the color image to grayscale conversions, grayscale to black and white. Why we are converting the colors? For the removing the noise and pixel imperfection and filtering, mid and median. Resize the image. To resize the image, decrease the or increase the size of image. Like what is the image size? 256 by 256. Height 250 height and 256 width. Next, color conversions. So what is the color conversions? We having the three types of images like color image and grayscale image, and next third one black and white image. So black color image having the three channels. So RGB, green, red, green, blue. So it take a RGB to gray color conversions. So take a mean value of RGB for each pixel, then it will be converted to a grayscale image. Next, filters. Why we are using filters? In image processing, mainly used for the filters, for the removing the reduce, for removing the noise, pixel information. Next, image enhancement. So why we are doing the image enhancement? These are the techniques of image processing techniques like image acquisition, image enhancement and filter applications and color conversions and resize, reshape. So these are the image processing techniques. So image processing, image enhancement is one of the technique of image processing. It is a procedure of improving the quality and information content of original data before pre-processing. So segmentation. Segmentation is nothing but partitioning of image. It has a cluster and threshold and for the edges detection. Next, image compression. So image compression is the process of encoding or converting an image file in such a way that it consumes less space than the original file. It is a type of compression technique that reduces the size of an image file without affecting or degrading its quality to a greater extent. Next, introduction to Python. So for the image processing technique, we are using one of the languages a Python. So what is the Python? Python is a open source language. It is a high level language. It is easy to understand in humans. So Python is an interpreted object-oriented language. It is a high-level programming language with dynamic semantics. Python is a computer programming language. It is used for the developing websites and softwares and automated tasks. Python was developed by Guido van Rossum at the National Institute of Technology and Computer Science in Netherlands. So Python is a high-level language, programming language. Its simplicity, readability and versatility created by Guido van Rossum and first released in 1991. Python emphasizes code readability and a clean syntax, making it an ideal choice for beginners. So easy to read syntax, interpreted and dynamic typing, multi-paradigm, rich standard library and cross platform, large community. What is read syntax? Python syntax resembles natural language, making it easy to understand, easy to learn. This readability helps maintainability and collaboration among developers. What is interpreted? So Python is an interpreted language, meaning that code is executed line by line interpreted without the need for compilation. This facilitates rapid development and testing. Python is a dynamic typing. So dynamic typing is nothing but allowing variables to be assigned without specifying their data type explicitly. The flexibility simplifies coding and speed up development. So next, multi-paradigm. So multi-paradigm is nothing but multiple programming paradigms including procedural, object-oriented and functional programming, allowing developers to choose the most suitable approach for the projects. Next, Python is a standard library. Python comes here with comprehensive standard library that provides modules and packages for various tasks such as networking and mathematics and web development, reducing the need for external dependence. Python is a cross platform. So independent, meaning that code run on different operating system without modifications. This probability makes it is a popular for developing cross-platform applications. Python is a large community. So Python was active community of developers, contributors and users who contribute to grow and provide support through like documentations. And Python is widely used in various domains including web development and data science, artificial intelligence, machine learning, scientific computing, automation and scripting. It is a versatile and easy of use. It is a valuable tool for humans. So in the Python we having the three versions like Python 1 and Python 2 and Python 3. The latest version is Python 3.1.2. Python 2 is a legacy. Python 3 is the present and future. Python 3 was released in 2008 and Python 3 don't have enough libraries. So that's why Python 2 also now and present we are using Python 2 versions also. Why we are using Python? For the website building the softwares and website developing purpose we are using Python. So artificial intelligence, robotics and quantum computing, web development, automation, testing and web scraping, blockchain and ethical hacking. Python we are using for the web development with Django. So next, Flask we are using for the web page creations. For the web page creation we are using the Flask with Python. And gaming applications also we are using for the digital gaming purpose we are using Python language. Next, coming to Python variables. Python variables, why we are using variables? So we are storing storing the data we are using the variables. So for the variables we having the rules. We cannot start with a integer values. So it should start with character or number. It contains alphabets 0 to 9 numbers. Variables is a case sensitive. So coming to Python data types, like we having in Python we having different types of data types. Like Python data types, numeric data types and dictionaries, booleans, and set data types and sequence data type. So integer, coming to numeric data types. In the numeric data types we having the integer, complex and float. So integer data types. Integer represents whole number without any decimal points. What is complex data types? So real place, imaginary parts is nothing but complex numbers. What is float data types? Float data type is nothing but represents floating point numbers with a decimal point. What is strings? What is dictionary data types? Dictionary's data type is a pairing key values. What is Boolean data types? See, Boolean data type is a true or false condition. So next, set data types. So set data type is nothing but tuples, list, sequence data type. Strings, list and tuple. Strings is nothing but represents sequence of characters enclosed within a single quotes and double quotes or triple quotes. What is Boolean data types? It represents the values true or false used in logical operations and control. What is list? Represents order collections of elements which can be different data types. Lists are mutable, meaning they can be modified after creation. What is tuple data types? So similar to list but immutable, meaning they cannot be modified after creation. Tuples are typically used for fixed collections of elements. What is set data types? So set data type is nothing but represents unordered collections of unique elements. Sets are mutable but they do not allow duplicate values. What is dictionaries? So dictionaries is nothing but collection of key value pairs where each key is associated with a value. Dictionaries are unordered and mutable. Next, binary data types like byte, byte array and memory view. Next, installation of Pythons. How to install Python? First we need to go to website python dot. So this is the home page of Python. The latest version this is the latest version Python 3.1.2.2. So we need to install Python. So how to install Python? Go to files option. The latest version is 3.1.2. So go to download options and go to files. Here in Python we having the three versions, Python 1 and Python 2 and Python 3. In the Python version subversions we having, and Python 2 also we having the subversions, and Python 3 also we having the subversions. See here release version and release date. So I need to download now 3.11.8. So I am downloading here. Click on the download option and go to. So first we need to check operating system, that is 64-bit or 32-bit. My system is 64-bit, so that's why we need to install Windows 64 installer. So go click on the 64-bit installer and download. This is the process of installation of Python. Add Python to path. So click on add Python and install. Click on install now. This is the process of installation of Python. So in Python we having the libraries like NumPy and Matplotlib and OpenCV. In the image processing mainly we are using the OpenCV library we are using. For the why we are using OpenCV. This is the process of installation of Python. And next, add to Python path, and next hands-on session. So how Python is a interactive mode. So why we are using the interactive mode? It is a line by line execution process. It is in the interactive mode. What is script mode? We need to write the number of lines of program in a script mode. So in the interactive mode is nothing but short number of lines of code is executing in the interactive mode. Coming to script mode. Script mode is nothing but we need to write the number of lines of code in the script mode. So next, types of programming process. So compiler and interpreter. So compiler is nothing but source code is converted into the machine code. So then we will get output. What is interpreter? So Python is a interpreter language. Why we are calling Python is a interpreter language? Source code converted into the object code. So that's why we are calling the Python is a interpreter language. So introduction to OpenCV. So OpenCV. So what is OpenCV? OpenCV is nothing but computer vision. It is a open source computer vision library. Is an open source computer vision and machine learning software library. It is a wide range of functionalities for processing and analyzing the images and videos including. So image processing. OpenCV offers numerous functions for basic image processing tasks such as filtering, transformation and segmentation and feature extraction. So next, in OpenCV techniques, object detection and recognition. OpenCV provides pre-trained models and algorithms for detecting and recognizing the objects in images and videos using techniques like hair cascade, histogram of oriented gradients, and deep learning based approaches such as convolutional neural networks. So feature detection and matching. OpenCV includes algorithms for detecting and matching key points and descriptors in images. Next, camera calibration and 3D construction. OpenCV supports camera calibrations, stereo vision and 3D reconstructions techniques and allowing for depth estimation and 3D scene reconstructions from multiple images. So next, video analysis. So video analysis is used for the OpenCV provides tools for video processing including video capture from frame manipulation, motion detection and tracking. What is machine learning integration? So machine learning integration, that also we are using OpenCV library. OpenCV integrates with machine learning libraries such as sklearn and TensorFlow, enabling the development of customer computers vision applications using machine learning algorithms. So for the graphics and visualization, we are using the OpenCV functions. So drawing the shapes, text and annotations on images and videos as well as tools for visualizing the data results. So for the OpenCV, various programming languages we are using including Python and MATLAB, making it accessible to wider range of developers. For the industry applications, we are using in the OpenCV, we are using the industrial applications like robotics, augmented reality and autonomous vehicles, medical imaging and surveillance. And additionally, OpenCV actively regularly updated with new features and improvements. So in the few features of OpenCV. So OpenCV. So OpenCV is nothing but computer vision for the surveillance applications and medical images. We are resizing the images and reshape the images for the display the images. For the reading the images, we are using the main OpenCV library. Next, for the face recognition. So for the face, how it will recognize the face? With the help of OpenCV, we are recognizing the face. In a human face having 68 landmarks. Based on the 68 face landmarks, we will recognize the face. For the recognizing the face, we are using the hair cascade classifier. So based on the features like data set, we are using the face. So human activity using OpenCV. So here we are using the OpenCV library for detecting the human. So how it will detect human activity? Like diving, goal swinging, kicking, like based on the landmarks, based on the body landmarks, we are detecting the human activity like running or skateboarding, swing bench, swing side, walking. So based on the full body landmarks, we are recognizing the human activity. For the we are using OpenCV library. So for the landmarks recognition purpose, mainly we are using the media pipe for the detecting the landmarks. Next, this is also one of the applications for the OpenCV, like traffic sign applications. So next, medical applications. For the medical applications also we are using the OpenCV. In medical applications, like here we are using the medical images dataset. We are using for the images dataset, we are taking the images for the dataset, reading the images and resize the images and display the images, and for the visualization the images we are using the mainly OpenCV library. Next, this is also one of the applications of OpenCV, agriculture applications, like here crop disease detection using OpenCV. How it will find out the crop disease detection? In the data set we are using the crop diseases. In the crop disease data set we are taking the for the crop disease or medical images. In the image processing techniques, we are collecting the data from the Kaggle website and GitHub. One of the famous website is a Kaggle for the downloading the data set. So here this is also one of the application AI for agriculture. So in the agriculture field we are here detecting the crop disease detection. For the crop disease detection input, we are taking the one of the image of the crop data set. In the data set we are taking the multiple images. In the multiple images we having the 2D images we are collecting from the Kaggle website. So from the data set we are applying resize, reshape. In the data set also we having the number of extensions like JPG, JPEG, PNG. So for that also, for the misunderstanding purpose, we are giving to the images. For all the images we are giving same extension. Next, this is also one of the application for the humidity checking purpose. In hardware also possible to check the agriculture monitoring application with the help of OpenCV. So in the farmer we are detecting the like crop disease or not in the agriculture field. How it will detect like a drone capturing videos or images, capturing the videos or images from the, like in the future drones or mobile phones we are uploading the one image from the capturing the drone or mobile phone with the help of OpenCV. So in the with the Raspberry Pi for the hardware applications also it will implement in the OpenCV library. With the help of OpenCV we are using Raspberry Pi also. And in the Python we having the libraries. What is NumPy? So what is NumPy? NumPy is nothing but storing the data of array. We are storing the data of array format. For that we are using, and mathematical calculations we are using the NumPy package. So NumPy we having the three types of dimensions: 1D, one dimensional arrays, and 2D dimensional arrays, and 3-dimensional arrays. So uses of NumPy for the arithmetic operations, statistical operations, and bitwise operations, and copying and arrays. So searching and sorting, mathematical applications, broadcasting, linear algebra, matrix operations. So next, image processing. So with image processing with OpenCV. So what is the image processing and OpenCV? What is the use of image processing and OpenCV? For reading the image, resize the image, for the display the image. So I am showing is nothing but display. This function is used to read the image. This is the display the image, and here from the OpenCV. So for the OpenCV shortcut name as CV2. So from the OpenCV we are reading the images and displaying the images and saving the images. So writing is nothing but saving the images. Next, pre-processing are images and videos. Input in image processing techniques using OpenCV. Input dataset we are taking the images, videos. So reducing the complexity. So resize the images or resize the videos, and color conversions the images and videos, like color image, color conversions, color image to resize image. So resize image to grayscale conversions, grayscale image to black and white conversion. So practically I will show you what is deep learning. So deep learning is a powerful tool Deep learning is a subset of machine learning that involves training artificial neural networks with multiple layers to learn from data and make predictions or decisions. Deep learning algorithms are inspired by the structures and function of the human brain, with layers of interconnected neurons that process information hierarchically. So in the deep learning we having the different types of algorithms. So artificial neural network and deep neural network, convolutional neural network, and recurrent neural network. So what is artificial neural network? So this is the types of deep neural networks. Artificial neural networks like ANNs, deep learning models are typically and built using artificial neural networks, which consist of interconnected nodes organized into two layers. Each node or neuron in a neural network performs a simple computation and passes it out the next layer. What is deep neural network? So deep neural network with multiple hidden layers between the input and output layers. These hidden layers allows DNNs to learn complex representation of the input data through hierarchical feature extraction. Next, convolutional neural network. Convolutional neural network is a type of deep neural network designed for processing structured grid-like data such as images. Convolutional layers to extract the features from input images, and pooling layers, downsamples, reduce spatial dimensions. CNN are widely used in image recognition and object detection and image classification. What is recurrent neural network? So RNN are a neural network design processing sequence of data such as time series, natural language. RNN commonly used in tasks like speech recognition, language translation and text generation. This is the structure of feed-forward neural networks. In we having the three layers. So input layer, hidden layer and output layer. Reinforcement networks. This is a convolutional neural network. Convolutional neural network having the three layers. First is convolution layer, max pooling layer and flattening layer. So after the three layers we are applying to the one model. Like in the CNN model, in the CNN algorithm we having the different types of models. For the examples of dense model and VGG16 and resident models. See, CNN is a multiple layered neural network with a unique. So real-time examples like virtual assistants like Siri and autonomous self-driving cars and chatbot and face recognition and shopping and entertainment. Self-driving cars. For the self-driving cars also we are using the natural extensions for the activity, active safety and obvious. Sentiment analysis. What is the sentiment analysis? For the customer related, customer sentimental based. Virtual assistant. Virtual assistant examples of personal assistant like Siri and chatbot, online training websites. Healthcare. Healthcare medical chatbots. So today image processing techniques like image color conversions, resize the images and read the image, how to read the image, how to save the images and how to display the images. Practically I will show you, and today main application of brain tumor detection using image processing. How it will detect the person having tumor or not with the help of image processing OpenCV. How it will detect based on the data set of images. So this is the stages of tumors like no tumor, glioma tumor. This is the structure of brain tumor. First I will show you how to read the image, how to display the image, how to save the images. Practically I will show you. First we need to open Python ideally. For the image reading we need to install packages. So mainly we are using the packages NumPy and OpenCV package. So for the NumPy package we need to install packages. How to install package? First go to search bar and go to search bar, type here ideally, and now I am using 3.9 version. Here go to file option and open and go to scripts, go to file path, type here CMD. So from the scripts Python, from the Python 3.9 we are opening the command prompt. From the scripts we need to install packages. So for the reading the images and displaying the images, for the saving the images, mainly we are using the OpenCV library. So for the we need to install OpenCV library. How to install OpenCV library I will show you. I open the command prompt from the Python 3.9. In the Python 3.9 from the scripts we opened command prompt. So now I have to install OpenCV library. For the OpenCV library, pip space install space OpenCV -Python. In the Python I am installing the OpenCV library, and next click on enter button. Already I installed OpenCV library, so that's why it's showing requirement already satisfied. For the image reading and displaying the image and resizing the image and display the image, mainly we are using the OpenCV. So for the next, now I am opening the code, how to read image and how to save image. I am going to the location. See here I am importing the NumPy. So why we are using NumPy? So for the data set here, what we are using, input data set in the image process, in the deep learning techniques we are using the input as a images or videos or any audios or stored videos. So data set we are gathering from the Kaggle website. This is also one of the famous website for the downloading the data set. So here I am importing the NumPy package. What is the NumPy? What is the use of NumPy? So NumPy is a numerical Python. It is just store the data of array format, and as well as for the mathematical calculations we are using the NumPy package. So next, import CV2. So CV2 is nothing but OpenCV, computer vision. So here I am using the img variable name. Why we are using the Python variable? So why we are using the Python? What is variable? For the storing the data, for that we are using the variable name. Here I am using img variable name. So from the OpenCV. So for the OpenCV shortcut name, as I mentioned, the CV2. So from the OpenCV I am reading the one image name as download dot extension. In the images extensions we having the JPG and JPEG and PNG. So here I am downloaded the one image, that is this is the I am downloaded image. This is my image. This is a 2D image. Name as download, file name as download dot extension is JPG file. So that same image path name I am given here. I am reading the image, file name as download, extension is JPG, and from the OpenCV I need to display the image. For that I mentioned the I am show. So name as scenery. So here I am calling the name as download image I am calling. So I store the data of img variable. So same as variable name I am calling here. Next I am saving the image as output.png. So here from the OpenCV I am writing the image, like saving the image as output.png. So same as image variable name I am calling here. Next, color conversions. From the OpenCV converting the color, same as saving the images. For that I am converting the color. From the OpenCV we are using the OpenCV for color conversions, from the BGR to grey color conversions. Why we are converting the colors? For the removing the noise and pixel information. For the removing the noise, we are reducing the complexity. We are using the color conversions. Next, here I mentioned grey variable name. From the OpenCV we are converting the color. So from the color image to grayscale color conversions. So now I wanted to display the grayscale image. From the OpenCV I am displaying the image, that frame name as a grayscale. So next, black and white. So first I read the one image. Next I am saving the image. Next, color conversions. I am doing the color conversions. Next I am displaying the color conversions of a grayscale image. And next, black and white. So black and white is nothing but threshold. So 0 or 1. So range of 0 or 1. So this is the pixel ranges. From the OpenCV we are converting the black and white color conversions. I need to display the black and white image. From the OpenCV I'm showing is nothing but display as file name as frame name as black and white. Next wait key from the OpenCV within the 0 million seconds. Next from the OpenCV destroy all windows. We need to close all windows at a time. So I need to run the code as go to run option and run module F5. So this is the color conversions. So this is the main image. I am saving the image as a scenery image. See here I given one image, that file name as download, file extension as a JPG, and from the OpenCV I am displaying the image as a scenery. So scenery image, this is the original video, I am displaying the like scenery image, and next I am saving the one image as output. So saving image, it will automatically save the in our folder. See that name as I given name as output.png. This is the saving image. And a grayscale image and black and white image. And next we need to close all windows at a time. So we need to select output shell. We need to close. It will close at a time all windows. This is the reading the images and saving the images and displaying the image and color conversion in the image. Next for the stored video, this is the images based, and next I will show one more application for the video based. So this is the import. We are using the packages import numpy as np for the numpy package, shortcut name as np import cb2 for the capturing the videos and input whatever we are giving the input like images or videos. For reading the images and displaying the images and capturing the images, we are using the OpenCV package. Here I am giving the cap variable name as cap. From the OpenCV capturing the video, as here I given the stored video. Stored video name as I taken one video. I stored one video as name as input dot extension of mp4 while true condition. Why we are using for output satisfy continue looping purpose. We are using the while true condition. See here I am using the variable name as img whatever from first I am capturing the video from the stored video. So that video I captured video, I stored it in the cap variable name as cap. See I am reading the video here and displaying the original color video like as original color video. Next and resizing the image. So resizing the video as like frame size, height and width here, and displaying the resized frame, and here converting the color conversions. From the OpenCV we are using the color conversions. So gray BGR to gray color conversions, color image to grayscale color conversions, and here grayscale pixel information, black and white. If we CV to dot wait key within the 1 million seconds output it continue, it will be loop. Order of queue, if you need break the output means in the keyboard we need to enter Q keyword, so automatically it will break the output, and cap dot release, camera will close and destroy all windows at a time, it will be closed. So I am running here for the stored video. This is video process. Previously I showed for the image reading, writing and saving. So next, now I am executing for stored video. So this is also stored video. This is original video, this is resized frame video, this is the gray color conversions, this is black and white color conversions. For the mainly we are using the OpenCV package. For what is the OpenCV library use? For reading the images and resize the images and displaying the images. For the capturing the images, reading the images and saving the videos or images, and color conversions mainly we are using the OpenCV package. This is for the stored video. So we need to close all windows at a time. We need to close output shell. It will close all windows at a time. This is the process. And coming to next main. Today main application, brain tumor detection using image processing. How it will detect the brain tumor, person having brain tumor or not. So input here giving the MRI images of the brain image, pre-processing. So pre-processing is nothing but resize, reshape and color conversion for removing the noise and pixel information, and feature extraction. So for the feature extraction we are using the 2D vector images. Database we are taking the brain images. So brain tumor, so like stages of the tumor. So what are the stages we are taking for the brain tumor detection, I will say. And database we are splitting the two parts, for the one is training part and one is the testing part. So next for the training, and we are loading the data of training and testing. Then after we need to classify with one algorithm. In the brain tumor detection we are using the CNN algorithm. In the CNN algorithm we having the 3 layers. In the CNN algorithm we having 3 layers. One is the convolution layer and max pooling layer and flatten layer. So these convolution layer we need to load the data. So next max pooling layer, splitting of the data of we are using the max pooling layer, and flatten layer, filter applications for using the flatten layer. After completion of 3 layers we need to fit the one model. Why we are using models? So in the CNN algorithm we having the 3 models. So like number of models we having like dense model and VGG16 and resonate. So for why we are using the models means for the accuracy, optimizing the data we are using the models. So it will detect the tumor, a person affected tumor or not. If tumor affected means which type of tumor affected, it will detect in the image processing techniques. I will show practically. So this is the data set of brain tumor detection. In the brain tumor detection data set I gathered from the Kaggle website. So in the next pre-processing step. So pre-processing step, resize, reshape and color conversions. So for the classification purpose I am using here CNN algorithm. And next this is the training part, output 1 training. This is the epochs. Epochs is why we are using the epochs means like we in the data set we given like 100 images means 10 times here I given 15 approaches. So 15 approaches in the sense we need to train the 100 images is 15 times we need to train 100 images. This is the training part and this is the final output of brain tumor. Here import matplotlib. So for the matplotlib, why we are using matplotlib in the sense means for the graphical representation we are using the matplotlib. So this is the final output, it will come and practically I will execute in front of you peoples. So for the brain tumor detection I am using the Python language Anaconda Navigator. In Anaconda Navigator in Jupyter Notebook application I am using here. First we need to go to website and we need to install Anaconda Navigator, and in the Anaconda Navigator we need to open Jupyter Notebook and go to location. So for the brain tumor I am taking the data set of 4 labels. I am taking the data set, I am splitting up the data set training and testing. For the training I am taking the 4 labels like tumor levels. So tumor stages: pituitary tumor, neotumor, meningioma tumor and glioma tumor. So from the with the 4 labels I am taking the data set. This data set I am gathering from the Kaggle website. So this is the my data set. I am storing the operating system. So we need to give path name from the operating system to Anaconda Navigator Jupyter Notebook. This is the main code. So this is the package. First shell as a packages. So first we need to install packages in the Anaconda Navigator, and what are the packages we are using here means import numpy package. We need to here for the brain tumor detection we are using the data set of brain tumor images, MRI scan images we are using here, like with the 4 labels like 4 stages of brain tumor and no tumor images and 3 types of stages of brain tumor images we are taking. Here importing the numpy as np. Why we are using numpy package? But storing the data of array format, and sklearn cbond for the visualization, for the graphical representation purpose matplotlib we are using, and cv2 package for reading the images and displaying the images we are using, and import TensorFlow as CV. So mainly we are using the TensorFlow package for the loading the data of building the architecture of we are using the TensorFlow package. Matplotlib means, so for the graphical representation we are using the matplotlib package. Next, here I given the variable name of class names. I am loading data labels, types of tumors: glioma tumor, meningioma tumor, neotumor, pituitary tumor. So here I am giving the loading the data of training and testing. So here resizing the, see here I am reading the images, color conversions and images size. So for the all images I am giving the one size like a height and width 150 and 150 here. Next, from the operating system I am joining the path names. In my system path name I am given. Next, loading the data of training and testing. So next, how many images we are taking. Like I am displaying here number of training images and number of testing images. From the data set I am displaying like one graph. Here I am displaying the bar graph. Here I am displaying as data set of brain tumor. I am displaying as pie chart. Here also I am visualizing the data randomly from the training images. See here from the training the data set I am displaying the total data set of brain tumor images. Here I am applying the for the classification purpose for the brain tumor detection. Here I am using CNN algorithm. So I am model I am taking from the Keras, and for the CNN algorithm I am using Keras and TensorFlow. Why we are using TensorFlow means for the loading the data of training and testing, and Keras. So coming to Keras why we are using means image to array conversions we are using Keras package. So after in the CNN algorithm we having the 3 layers: conversion layer and max pooling layer and flatten layer. After flatten layer I am applying to the model. So here I am applying to the dense model. So for the accuracy, for the compiling the from the model I am compiling optimizers with the Adam optimizer. We are using the accuracy purpose we are using dense model. Here this is the training part of data set. Approaches values, this is the training part. Here I am using Resonate and VGG16 models I am applied here. This is the how much accuracy we will get with the CNN algorithm. Here 97% I get the accuracy, and how much training and how much loss. This is the one of the graph. So finally I given the from the data set from the glioma tumor input I given as a one image as glioma tumor based on the data set. Based on the training of the images, training of the data set, it will predict the output, the person having tumor or not. It is very useful in the future with the help of OpenCV and image processing techniques. In the medical applications like surveillance application, mainly we are using the image processing and OpenCV. This is the glioma tumor. I am displaying the data set of the confusion matrix. For the this is the precision and recall and F1 scores. Classification report of brain tumor with the labels of the data. This is the final output of brain tumor disease detection. So thank you for this giving opportunity, Sasi Institute of Technology and Convener sir and Co-ordinator sir. And feedback link also we shared, and attendance form also we shared. Within the 4 or 5 days we will issue the certificates. Yeah, thank you. If you need any internships or major projects or mini projects, please contact them. Thank you all.